A very lovely hello to all my class 9th champions, class 9th ninjas. So welcome back once again in Titan series, and this is my second lecture of Titan series, Advanced Math Bridge Course lecture number 2. But if I talk about for sets, so for sets this will be the lecture number 1, because I will be giving you one more lecture in sets. So 2 lectures will be there for sets especially, and sets is the first chapter of your advanced maths class 9th. So my dear lovely champions, I know you guys must be feeling little wonder to see my new look. I don't know how am I looking, so do let me know in comment section. Sir, this is your look. What I mean about my look. I myself feeling little weird. I don't know how am I looking beardless. So okay, let's talk about sets, lecture number 1, guys, and let's begin. So first of all, what is set? How to define set? What is set? So basically, listen everyone. Set is what? Set is a branch of maths in which we collect the few information in the form of object, information in the form of letter, information in the form of number, information in form of any object. So when we collect objects, numbers, letters, but there are few conditions, there are few rules. We can't go beyond those rules, following some rules. So basically set is what? Collection of information, collection of data, collection of objects, collection of number, collection of any shape, geometrical shape, whatever it can be, anything, but the collection should be well defined. So basically a set is a well defined collection of distinct objects. Yes, distinct objects. For example, just listen everyone, if I ask you, write a set of all the best footballer of the world. So you can't write it in the form of set, because if you go and search who is the best footballer of the world, so according to number of goal, some footballer will be ranking first. According to for example, defensive power, according to attacking power, according to midfielding capability, according to physical fitness. So there may be different criteria. So you can't write top footballers of the world. You can't. But if I give you the condition, top 10 footballers who scored maximum goals, now you can write the name of the footballer who scored maximum goals. The footballers who is ranking in maximum number of goals. So basically set is what? A well-defined collection of distinct objects. Right everyone? For example, if I ask you, write the set of all the even numbers less than 10. So less than 10 means well-defined. And we can write all the even numbers less than 10. So what will be the even number less than 10? Even number less than 10 will be 2, 4, 6, 8. So yes, this is well defined. We can write the set, which is valid to write. So basically a set is a well defined collection of distinct objects. Right everyone? Clear everyone? And we'll be talking about a lot of things about sets, infinite sets, finite sets, universal sets, lot of things are there. So first of all, understand the basics about sets. What is sets? So basically a set is a well-defined collection of distinct objects. Let me clear you by using this diagram. Look at the photo, look at the picture here, guys. Learn which is set and which is not set. So my dear, look at the diagram here. The set of even numbers less than 20. This is possible because this is well defined, the set of even numbers less than 20. So we know this is limited, this is finite. We can write all the even numbers less than 20. So the numbers will be 2, 4, 6, 8, 10, 12, 14, 16, 18. So this is obviously set because the given information is well defined. And this will be the collection of the numbers. So the collection of numbers, the collection of data, the collection of object, and should be well defined. Well defined. And do you know one more information is there? Distinct. Distinct means what? Distinct means what? The number, the data, or the elements. Basically these are called elements in set. I'm going to tell you these things later on, but yeah, let's understand. So 2, 4, 6, they are called elements. Elements of a set, or you can say member also. Member also. Okay, elements or member. 2, 4, 6 are the elements of the set. and we can say this is, for example, set A. We can name anything. You can label A set, B set, anything. So A is a set, and these are the elements or number, and always make sure to represent the sets using this. Can you see here? Braces. So this is the curly braces. This is called braces, basically. Curly braces. So basically we use this braces to represent a set, and we can name anything. You can write A, B, C, whatever, and these are the elements, and this complete representation is of set. Clear, everyone? So distinct means what? The number, the member, the element should not be repeating. If a number is repeating, if the number, for example, by mistake, if I have written here two times, 4 two times, so only one time will be considered. If the member is repeating again and again, it is not making any sense. So please ignore. If any element is repeating again and again, repetition is not allowed in a set. Clear, everyone? So that's why we are using distinct objects. Okay, so a set is a well defined. So this is set because this is well defined. The set of even numbers less than 20. Next, the set of prime numbers less than 15. Yes, this is also possible to write. We know the prime numbers less than 15. You know prime numbers, the number which is divisible by 1 in itself. So less than 1 is neither prime nor composite, so we have ignored. So first prime number is 2, then 3, then 5, then 7, then 11, then 13, because we are talking about less than 15. So this is obviously a set. We can write set, right, everyone? Now next, the set of a days in a week. Everyone knows in a week there are 7 days: Sunday, Monday, Tuesday, Wednesday, Thursday, Friday, Saturday. 7 days are there, so you can write Sunday, Monday, Tuesday, Wednesday. So obviously this is also a set. Well defined, and each element is clear. Well defined, and each element is clear. Well defined, and each element is clear, and this is called set. Clear, everyone? Clear? So set is what? The collection of data, collection of things. Well defined collection of set. Well defined collection of number, shape, object, person, whatever, and distinct, right? Okay, now look, these are not sets. So look at the first condition. The set of good students in the class, we can't decide. If there are 20 students in a class, for example in class 9th, there are 20 students, and if I ask you, from you guys, give me list of 10 best students, we can't decide, because some student, one student might be good in, sports, another student might be good in debate competition, another one student might be good in mathematics, another student might be good in attendance regulatory. So there are different criteria. We can't decide who is best, who is superior, who is inferior. We can't decide. So this is not well defined. We can't decide who is good and who is bad. Getting my point? So this is not well defined. So we can't write the set for this condition. So it can't be set. Clear, everyone? Because the set of good student in the class is not well defined. Good is a subjective, unclear term. We can't decide who is good and who is bad. This student might be good in communication. That student who is sitting behind at that last bench, that student might be good in logical, critical thinking. That student might be good in writing skills. That student might be good in speech. He might be a good speaker, or she might be having good leadership skills. So we can't decide which student is good and which student is bad. So this set is not possible. We can't write set for this, right, everyone? So this is not well defined. Let me switch on the light. Few lights are switched off. Okay, now it's good. Clear, everyone? Clear, everyone? So now moving ahead, second point, the set of beautiful flowers. Will you be able to decide which flower is beautiful and which flower is ugly? Every flower is good and bad. I mean, every flower at their place is good. Some is having red color, some shapes are different, some is having yellow color, some flowers shapes are different. Few people love this flower, few people love sunflower, few people might be loving this lotus, few people might be loving this flower. So we can't decide which is beautiful. This rose might be favorite for few people, it might be favorite of few people. So we can't decide which is beautiful flower. In my opinion, if you ask from me, sir, which is your favorite flower, I will say this, rose. Rose will be my favorite flower. If you ask from any other guy, he or she might be saying you, my favorite flower is lily or lotus, right? So we can't decide. They might be arguing with you, no, lotus is beautiful than rose, and sunflower is, beautiful than lily or whatever is there. Guide me. So we can't decide which flower is beautiful. So this is also not well defined. So we can't write the set for this. So beautiful is subjective. Not this is not in, this is subjective, so we can't write in number, we can't write in set form. Okay, moving ahead. The set of intelligent people. Again, intelligent is also subjective. So intelligence might be of different parameter of intelligence are different. Some some people might be intelligent in measuring dimensions, doing calculation in mind. Some people might be having intelligence ability in politics, to understand what's going on in surrounding, their basic understanding in politics. Some people might be good in their intelligence power is good, might be good in maths, calculation. They can solve even a lengthy multiplication just in a fraction of a second in mind. So intelligence, the power of intelligence varies from one people to another people. It depends on different parameter and criteria, right? So the set of intelligent people is not well defined, so it can't go in set form. I hope you guys are getting my point. So sets is what? Set is well defined collection. Well defined. Right, so the definition of set is a well-defined collection of distinct objects. Okay, moving ahead. So a set is a well-defined collection of distinct objects or elements if we can clearly decide whether an object belongs to the collection or not. It is a set. And this, the elements, it may be number, it may be people, it may be an element, geometrical shape, it can be anything. But the condition is, to write a set, the situation must be well defined. Otherwise, you can't write set. Okay. Remember, clarity makes a set, confusion makes it not a set. Yeah, this is obviously. If I ask you, who is most intelligent student in the class? So generally, at class level, you guys thinks that the student who is getting full marks in every test is the intelligent. No, my dear. The backbencher might be intelligent. A backbencher student might be an intelligent. He might be having or she might be having good critical thinking. She might be having, they might be having good innovative skills. They love in doing some innovations to invent something, right? So your marks don't decide like you are the intelligent. Sometimes your critical thinking, your observation, your body language decides your intelligence power, right? So please keep it in mind. Your marks gives you position, gives you eligibility, but everyone please focus. Your critical thinking, your observation and your brilliancy decides your career and decides your future. So please believe in yourself, recognize your inner potential, guys, right? So don't chase marks, chase concepts. Chase concepts, whether it is in maths, whether it is in physics, whether it is in science, chase concepts. Marks will automatically come. Marks will automatically reflect on your mark sheet. So don't chase marks. Okay, so this is all about clarity. Clarity makes a set and confusion makes it. So in these three, if you look at, these are not sets. In these three, confusion is there. We can't decide which flower is beautiful. We can't decide who is good student. We can't decide who is intelligent and who is, dumb. We can't decide. But here everything is clear. If I ask you, write the days of a week. Clear. Fixed. Sunday, Monday, Tuesday, Wednesday, Thursday, Friday, Saturday. These are the days. This is fixed. So clarity give you set. Confusion give you. So in these three, confusions are there. Okay. Now again, look at this. So few examples are there, guys. Example of sets so well defined, condition must be well defined. So the set of vowels in English alphabet. So this will be sets. A, E, I. This is not the proper representation. This is not the proper representation. Always represent a set in curly braces. The bracket should be like this. This is all the elements must be inside this braces, right? You can name anything, A, B, C, D. You can call a set anything, but the members must be inside the curly braces. Okay, so A, E, I, O, U. So this is set. The set of even natural numbers less than 10. So 2, 4, 6, 8. So this is set well defined. The set of months with 31 days. We can write, na? The set of months, 31 days, we know 31 days months are there. How many months are there having 31 days? How many months are having 30 days? This is also well defined. We can write the name of all the months here. Okay, not this bracket again. So the brackets must be curly, this one, like this. Clear everyone? And all the months which is having 31 days we can write inside this braces. So this is well defined. Okay, now which are not a sets? Listen, the collection of tall students in a class, we can't decide who is tall perfectly, right? So the collection of tallness is again adjective, right? So the collection of tall student in a class, tall differs from person to person. Yes, so we can't write the set for this. So this will not give you, this is not defined. The collection of beautiful flowers, again beautiful is a matter of opinion. Yes, it may vary from one person to another person. You may be saying rose is most beautiful. Some other, your friend might be saying no, sunflower is the most beautiful flower. And some student sitting besides you, he or she might be saying no, lily is most beautiful. So it varies according to opinion. So you can't write a set for the most beautiful flowers, right? So it will not give you set. The objects in a set are called its element or members. I have already told you, when you write any object, anything inside the curly braces, so it is called element or member, elements or member, and this entire is a set. This is the proper representation of the set. Clear everyone? So I hope you guys must have understood the basic concepts of a set. Moving ahead, I have already described these things. Okay, now let's talk about notation and symbols. Okay, so my dear champion, look at the first point. Sets are named with capital letters. Yes, you can use A, B, C, D, X, Y, Z, whatever you want to use to name the set. For example, if I ask you write a set of odd numbers less than or equal to 9. Write a set of all the odd numbers less than or equal to 9. So 9 will also be included, because listen my statement. I'm asking to write the odd numbers less than or equal to. So 9 will also be included. Now to write the set, you can take anything from this alphabet. For example, I'm taking B. So the sets will look like curly braces. And what I have asked you guys, all the odd numbers less than equal to 9. So 9 will be also included. 9 will also be included. 1 is an odd number. 1, 3, 5, 7 and 9 will also come. So this will be the set. Can you see here? And the bracket must be like this. So this will be the set. All the odd numbers less than equal to 9. 1, 3, 5, 7, 9. And look, to represent the set, I am using any one of the capital alphabet. So to name a set, always use a capital letter. But if you want to show the elements by alphabet, if you want to show the elements of a set, members of a set using alphabet, so the elements are written in a small letter. Small letter. Right, everyone? For example, if I ask you a set contain all the letters before X, all the letters before H. A set is of all the alphabetical letters before H. Before H. So for set you can say anything. I mean, for A is the set and all the letters before H. So A, B, C, D, E, F and G, because I've asked you before H. So before H till G will come, from A to G, and this is the curly brace A, B, C, D. So my dear, sets are named using capital letter, and if you want to if you want to show the elements using alphabet, so elements will be representing using small a, b, c, d, whatever you want to write. Otherwise you can write anything. The members can be any number, any person's name, month name, week name, weekdays name, anything, right? So this is all about. Moving ahead. Okay. Next, elements are enclosed in curly brackets. So this is the, can you see? This is the representation. Elements represents in curly brackets always, and these are the elements too. These are the elements 2, 4, 6. These are the elements. Clear everyone? These are the elements, and curly brackets is the representation as per the set theory. According to set theory, everything comes in set theory, right everyone? Everything whatever I'm teaching you here, it comes in set theory. Okay, so according to set theory, sets are named using capital letter, elements are written in a small letter if you are representing element in alphabet, and elements are always enclosed in curly brackets. If you use this bracket or this bracket, your marks will be deducted, because this is strictly comes in notation. This is the rule of set theory. The elements should be enclosed in the curly braces. Okay, moving ahead. Next we have two symbols, guys. We have two symbols. First is belongs to represent as this is E, and second is not belongs to. E will be crossed. Writing E will be crossed. Belongs to, not belongs to. This is the symbolic representation, and in words you have to say belongs to. This is the symbolic representation, but in words it will be pronounced as not belongs to. For example, listen, when and how to use. Listen, if 4 is in set A, if 4 is an element in set A, so we can write 4 belongs to A. For example, I have a set here 6, 9, 12, 15. This is the set, right? Now I can write 6. 6 is an element of this set. It means 6 belongs to set A. So we can write 6 EA. This is called as 6 belongs to A. Now if I ask you, what about 13? Is 13 an element of this set? 13 is not present in this set. 13 is not an element. So 13 is from outside of this set. So it will be representing as not belongs to. 13 not belongs to A. So in words we can say 30 not belongs to A. I hope this is clear to you. So capital E, this E type, this is Latin word, okay, and E means belongs to, and E crossed means not belongs to. And when to use? If an element is present in the set, we can write that particular element belongs to. If an element is not present in the given set, so we can write not belongs to. Clear everyone? So these are the notations and symbols that you should always keep in your mind whenever you are doing the questions. Moving ahead. Okay, now there are few standard set of numbers. So these are the set of numbers. Basically capital N represents the natural number, and the set for natural number will be again curly brackets, and natural number starts from 1 to till infinity. We don't know what will be the ending digit. We don't know. It goes on. So dot. So dot represents and so on, because we don't know the ending value, which will be the last number till infinity, right? So we can write natural number set N equal to braces 1, 2, 3, 4 and so on. This will be the natural number set. For example, W represents whole number. So for whole number, the set is written as W represent the name of set, and again we required curly brackets. And whole number means what? 0 will be included in natural number. So from 0, 1, 2, 3 and so on till infinity. Again curly bracket should be there at the closing point. Now Z represents the integers. So do you know integers? All the negative value, positive value including 0. All the negative value, positive value including 0 will be natural integer, and integer is represented as capital Z in number system, right? So let's talk all the negative means till infinity, minus infinity. So dot will come, and let's start with -3, -2, -1, 0 will come, then positive value, right side positive, left side negative, 1, 2, 3 and so on till positive infinity, negative infinity till positive infinity. So Z will represent integers. So this is called set, because this is the collection of all the integers, this is the collection of all the whole numbers, this is the collection of all the natural numbers. Okay, now Q represents the rational numbers. Do you know rational numbers? Rational numbers, the numbers when the numbers are written in fraction form, where denominator should not be equal to 0, right? Where q should not be equal to 0. So q represents the rational number. R represents the real number, champion. Real numbers means what? The collection of all rational plus irrational. Rational plus irrational, all the rational plus irrational number, this will give you real numbers. This is the real number. So the bunch of the combination of all rational or irrational number means real numbers. Clear, everyone? Now, one very important thing to be noticed here: order does not matter and repetition is ignored. This is, everyone, important. So most important thing here, for example, if I am writing a set 2, 3, 4, right, and again I am writing this set as 4, 3, 2, and again I am writing this set as 3, 2, 4. My dear champions, in set theory, if you changing the order of the elements, no impact will be there. There is no any disturbance. Nothing will be there. If you are changing the order of the place, nothing will happen to the theory. It will remain as it is. But if an element is repeating, please ignore the repeating. Repetition will not allowed. If an element is repeating 2, 3 times, you have to consider single time. Alright, everyone? Clear, everyone? So repetition is not allowed. Changing the order is allowed. Look, order does not matter and repetition is ignored. So if repetition is there, please ignore the repetition. But if you are changing the order of the sets, no problem is there. There will be no any impact on the set. Clear, everyone? Moving ahead. Okay, now let's talk about representation. So how to represent the sets? Basically, my dear, sets are represented by two forms. There are two formats by which we can represent the sets. So let's talk about the first representation is called roster form. It is also known as tabular form. You can say roster form or tabular form, both are same. So what is roster form? Listen, everyone. So basically, whatever I have told you so far here, all are roster form. These are called roster form. When we write the elements using comma inside the bracket, right? There is no any language. I can write in language also. For example, x are the elements, so x such that all natural number. So that will be some other format. But if we are representing the numbers using comma in curly brackets, so this is called a roster form. So I have written all the so many sets here also. So all the sets are basically roster sets. Okay, listen. So in roster form, we list all the elements separated by commas inside curly brackets. Right, everyone? There must be comma. For example, set of vowels. So for vowels, I'm taking set name is V and curly brackets, and vowel, we all know all the vowels are A, E, I, O, U, and we are using comma in between each vowel, A, comma, E, comma, I, comma, O, comma, U. So this is called this roster form. When we represent a set using comma between each elements inside the curly bracket. So this is called roster form. So this is here, which form, champion? Roster form. This is called roster form. We have one more form. I'm going to teach you here next, set builder form, but have patience. Roster form is clear. Next we have one more example, set of odd numbers less than 10. So all the odd numbers less than 10. So all the odd number, 1 is also odd number, 1, 3, 5, 7, 9, and do you know all commas are there, numbers are there. So for all the odd numbers is representing as capital A, the name of the set, curly brackets. So this is also what? Which form, champions? This is also called a roster form. Clear, everyone? When we represent all the elements, the member of the set using comma between each element and all the elements must be in curly bracket. Curly bracket is evergreen part, that must be there. Whether the representation is roster form or set builder form, the curly brackets will be there. Without curly bracket, set is not properly represented. Okay, now set of letters of word school. Now my dear, listen everyone, in school O is repeating 2 times, but when you write set, what I have told you guys, repetition is ignored. Repetition is ignored. So my dear champion, when you write set for this, you have to write O only 1 time, because O is repeating twice. O is repeating 2 times. But when you write sets, the repetition will be ignored. Only 1 O will come. Don't write 2 times. So let's say set is, I'm writing set name is S, but S is already there in the form of element. So let's say I'm writing the name of set is A, curly bracket, and the set is asking set of letters of the word school. So S is there, comma, C is there, comma, H is there, comma, O is there, comma, only 1 time O, and then L will come, curly bracket. So this will be the set. O is written only once because O is repeating twice, and this is according to rule of the sets. If the repetition is there, only 1 element will come when you are writing the roster form. So this is called roster form. Moving ahead, set of natural numbers. So natural numbers are represented as capital N, and we know natural numbers start from 1 till infinity. I don't know what will be the last natural number till infinity. So 1, 2, 3, 4, dot, 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 dot. Dot shows the list continues forever, because no one knows what will be the last natural number. It will go till infinity, right? So this is called, can you see? This is basically roster form. I hope this is clear to you all class 9 student who is studying for the first time sets. So roster form is clear. Bracket, curly bracket, elements, and in between all the elements, comma will be there. Moving ahead. Okay, what you should remember? Please, rules to remember: never repeats an element, and this is the example. Here O is repeating twice, but when you are writing set, only 1 time will come. So never repeat an element. Second, order of listing does not matter. Yes, for example, if you want to change the order of the set, by mistake a student has written this same set as C, H, O, S, L, L, no problem. There will be no impact on the result. Yes, you can write same S, now S is here, C is here, H is here, O is here. The order has changed. There will be no impact on the result. This is also approved. This is also valid. So order of listing doesn't matter. Okay, use 3 dots. Use 3 dots when the pattern is clear and the set continues. For example, natural number. No one knows what will be the last natural number. So we can use 1, 2, 3 dots and so on. So dot represents this set is going forever. It is continuous forever. Right everyone? So these are the basics that you should remember. So this is the roster form, which is also called tabular form. Moving ahead, second representation of set is set builder form. What is builder form? My dear, listen, I am giving a short trick. So builder form means building. It looks like this word is a little related to building, and building is what? Structure. To get a flat, to get a flat apartment, interior design, modular kitchen, that is the secondary thing. First you have to make the structure, building. You have to ready with building structure, then only you will be going through the decoration, the interior designing, electricity, different kind of interior works. So first is structure. Without structure you can't do these things. Decorating the building from within, you can't do this. So first you need structure. So to write any set, we need a structure, a building. For example, if I ask you, write a set of all the even numbers less than 4. Write a set of all the even numbers less than 4. So this is the building, the language that I'm giving you. Write the set of all the numbers, even numbers less than 4. So this statement is basically builder form. Building I'm giving you. And now you have to write all the even number. So even number only 2 will come. right everyone? So set builder form means the description, the language, the information that is given to you, and according to that information you have to write the roster set for that. So look at the screen. Instead of listing elements, we state the common property that all elements share. So basically description will be there, English language will be there, and after reading the language you have to write the sets in roster form. So the English language is set builder form. Yes, listen. So general format, general shape is A is equal to X, and these two dots, can you see these two dots? These two dots are called such that means X depends on this statement, X such that X satisfies a property, there will be a property. So these two dots, you know, in maths, in advanced maths CBSE, you know, such that this symbol is also representing you know, by this line. So if two dots are there or a vertical line is there, both, the meaning of both is such that. So don't worry champion. So the official advanced maths released by CBSE, in that book basically this line is using. So there is no difference between these two dots and that. If the line is there, say such that. If two dots are there, call such that. Both are same. Okay. So for example, look at example champion. So we have this. What is this? Wow, this is roster form. Bracket is there. 2, 4, 6, 8. Now for this information, we can make a building. We can make an English language. You look at the numbers. 2, 4, 6, 8. It looks like that all the numbers are even numbers. All the numbers are even numbers. And after 8, which will be the next even number? 10. So all the even numbers less than 10. So for this roster form, we can write this building X. Let's say X are the elements, X. So X such that X is an even natural number and X is less than 10. So according to this description, this language, we can write this. So roster form and set builder form, both are related to each other. Both depends on each other. Right everyone? So this is called set builder form. Can you see? This is basically, what is this? Set builder form. Set builder form. Because it is structuring a building, and this is the result. These are the flats, flat, kitchen, dining room and all. And this is the building. So roster value, these elements depends on the set builder. For example, 1, 4, 9, 16, 25. So all the numbers are perfect square. So for these numbers, we can write set builder form X such that X is equal to n square. And n belongs to, E means belongs to natural number, and n must be equal to less than 5. Yes, if you put here, listen, second question. Second is 1, 4, 9, 16 and 25. Right. So my dear lovely students, listen, look at the numbers. All are perfect square. So X such that X is equal to n square. If you put here 1 square will be 1. If you put here 2 square will be 4. If you put here 3 square will be 9. So here X such that X is equal to n square, and n belongs to natural number, and n must be less than equal to 5. Why? Because when you put here 5 square will be 25, and 25 is the last element of the set. This is the last element. Right everyone? If 36 would be there, so it would be look like n is equal to less than 6. So that if you put here in 6 square will be 36, but the last value is 25. So this will be the what? Set builder form. This will be the set builder form. Right everyone? So to write the set builder form, you guys have to focus on the roster form. So this is called roster form, and this is basically set builder form. I know this will be little challenging initially, but when you do lot of questions, when you do practice more questions from your advanced textbook, you will become ultra pro in sets. This is really very easy chapter. Clear everyone? So this is roster form, this is set builder form. This is set builder form. For example, one more. A, E, I, O, U. Again, this is roster form because only, objects are there. Object means vowel letter, alphabetic letter. And for this, we can write X such that X is a vowel of the English alphabet. We all know how many vowels are there in English alphabet? 5 vowels are there. So A, E, I, O, U. So this is set builder and this is roster. So set builder means English description, English language, and roster means the elements will be there directly in the form of number, in the form of person, in the form of anything. No language will be there. So this is all about everyone. I hope these things are clearing for you. Okay, no. Converting between the two forms is a favorite exam question. Yes, my dear. So get ready to get these questions in your exam, whether it is in half-yearly exam or in your final exam. These questions definitely come in exam. Convert the roster form into set builder. Write the roster form of given set builder. So the question might be there in conversion. Okay, so converting between, this is very important. Read. How to read, champion? Listen. How to read this? Read. X double dot means such that X belongs to natural number and X less than equal to 4. So this is basically what? This language. Set builder form. Because no elements, no comma is there. This is the set builder. And for this, we can write set. For example, X belong to natural number and X must be less than equal to 4. So how many natural numbers are there? 1, 2, 3 and 4 will also be included. Why? Because in set builder, X is less than or equal to 4 is there. Can you see the equal sign? There is a single line below the less than sign. So X less than or equal to 4. So this will be the set. And this will be what? Oh my God, this is roster form. Because elements are there with comma. So this is roster form, this is set builder form. Clear everyone? I hope this is clear to you, the difference between set builder form and roster form. Moving ahead. So let's do few questions here. Okay. Write the following sets in roster form. How to write in roster form, champion? Look how to write. So set of whole numbers less than or equal to 5. Roster means what? Comma between each elements, right? This is comma between each elements. Simple. So and there should be a name of set. So we are talking about whole number, so let's W is equal to curly brackets. The question is asking to write roster form. So direct set of whole numbers less than or equal to. So 5 also will be included, and whole number means 0, 1, 2, 3, 4 and 5. This will be the set of whole numbers less than or equal to 5. Clear? Moving ahead. Set of first 4 terms of an AP whose first term is -3 and common difference is 4. Very easy. Do you know AP? The new chapter that has CBSE introduced for the first time in class 9 maths, that is sequence. What will come next? I think that is the last chapter of your Ganit Manjari, sequence and progression. So look, set of first 4 terms of an AP whose first term is -3. So my dear, if first term is -3, what will be the second term? Second term will be A plus D. This is the formula in AP, and A we have first term is -3 and D we have 4. So 1 will come. Similarly, third term, for third term formula will look like A plus 2D, right? So A we have -3 plus 2 into D we have 4. 4 2 ja 8. This is -3. Okay. 4 2 ja 8. -3 plus 8 will be plus 5. Now A4, because the question is asking to write 4 terms. So we have to find out 4 terms. So 4 terms, fourth term formula will look like A plus 3D. Okay. A we have -3. D we have 4. So 4 3 are 12 minus, so this will come. So we have all 4 terms. So set will be, so for example, I am naming set as capital A. I have named this set as capital A. Again curly bracket, and sets will be 3 1 5 9. This will be the set. Clear everyone? 1 minus 3 will be minus 2. Is it clear? 4 2 are 8. Listen, minus 3. Yes, perfect. A plus D minus 3 plus 4 will be 1. Minus 3, 4 2 are 8. 5 minus 4, 1. Oh, this is minus 3, guys. Minus 3. Minus 5 minus 1, 4. 9 minus 5, 4. 1 minus 3, 4. Common difference is basically 4. So this is the set. Clear everyone? So these are the roster form. Clear everyone? Moving ahead. Okay, so this is clear to you all. I hope these two questions are clear to everyone, class 9th champions. So now moving ahead. Now in this question, write the following sets in the set builder form. If the question is asking to you write the given sets in set builder form, it implies that all are in roster form and it is clearly visible. Comma is there, elements are there and brackets are there. So it means already given in roster form and we have to write in set builder form. So let's do first question. So first question. So the first question will be, I'm solving first question. So this is set given here 1 comma minus 1. So set builder form will look like x such that, for such that we can use vertical line or 2 dots, both are same. X such that x is an integer. Yes, because positive 1 and negative 1 is there. X is an integer, and here can you see this is x square is equal to 1. If you put here positive 1 square will be 1. If you put here negative 1, minus 1 square will also give you 1. So this will be the set builder form for the given roster form. Clear? Moving ahead, second question. For this question, okay, this is fraction, and if you divide 2 by 3, so the result will be 0.666666. So this is repeating decimal. When you solve this, so if you solve the given fraction, so the fraction will give you the result as 0.6666 and so on. So we can write 0.6 bar. So this fraction is equivalent to 0.6 bar. So how to write in fraction, how to write in set builder form? Listen, x, first bracket, x such that x is equivalent, x is a fraction, 2 by 3 is a fraction, equivalent to what? 0.6 bar and bracket close. This will become what? Set builder form. Roster form, set builder form. So set builder form comes in description form, language form. Moving to the third. Okay, now third is 1 by 2, 1 by 2, 1 by 4, 1 by 1 and comma. Oh wow, this is really interesting. The question is so easy, but it is little confusing. So basically, just imagine, my dear champions, if here all the elements are in fraction, 1 is also fraction, guys, we can assume 1 by 1. 2 is also fraction, we can assume 4 by 2. 4 by 2 is equal to 2. Right, 4 by 2 is equal to 2. Okay, or 2 by 1 is also 2. So here, these are the fractions. So for numerator we can say A and for denominator we can say B. If you put here 1, let's say I'm putting A as 1 and 4 and B as 2 and 4. Now check all the fractions. So A by B, 1 by 2 will come. 1 by 2, 1 by 4 will come. Now 4 by 2 will be 2 and 4 by 4 will be 1. Check all the elements are present here or not. Wow, 1 by 2 is there, 1 by 4 is there, 1 is there, 2. The order has changed, but all the elements here and here, both the elements are same. So A should be 1 and 4 and B should be 2 and 4. Right everyone? A should be 1 and 4 and B should be what? 4 and 2. If you write 4 here, so and 2, so 4 to 4 by 4 will be 1. Yeah, so we can write this right in 4 by 2 form. So exact same elements will come here. So basically now the set builder form will look like bracket A by B let's don't write x, because the fraction, you can write x by y, but here for fraction I'm taking a by b. I have already told you guys, in element, in under brackets, always take small alphabet, don't take capital alphabet. If you are taking x, take a small x, or you can take anything a b c d. So a by b is a fraction such that a should be a equal to 1 or 4, and b should be equal to what? 4 or 2. Yes, my dear champion, bracket close. This will become the set builder form for the given roster form. Clear? So these are the roster forms and these are the set builder form. Clear, everyone? So set builder form contain English language, description, and roster form only elements. Okay, moving ahead. Few more questions. Write the following sets in a roster as well as set builder form. Wow, logical question. Okay, the first question is real numbers between 2 and 5. So write the following sets in the roster as well as in set builder form. My dear champion, listen. Here the question is asking real numbers between 2 and 5. First of all, how many real number will be there in between 2 and 5? So many. 2.1 is also a real number. 4.25 is also a real number. 4.2513 is also a real number. So there are so many real numbers. And I don't know which should be the first real number and what will be the end real numbers. This is not confirmed. So for this statement, we can't write a roster form. So first question, roster form is not possible. Yes, my dear, it is not necessary that for everything we can write set. For every well defined, for every condition, for everything, set is possible. This is not confirmed. Set depends. Sets also follow few ethics, few rules. So roster form is not possible for this. But set builder form we can write. This is also set builder form. So set builder will be what? X is such that X, all real numbers between what? 2 and 5. So set builder form, bracket close, curly bracket, set builder form is possible for this, but roster form is not possible for that. Clear, everyone? Roster form is not possible for that. Second question. Okay. Fractions whose numerator and denominator are natural numbers. Wow. Natural numbers, and denominator exceeds the numerator by 1. Wow, what a question. Denominator exceeds the numerator by 1, champion, by 1. So what will be the condition? If you write 1, 1 by 2. If you write 2, 2 by 3. If you write 3, 3 by 4. This is very easy. Listen, champion, first understand. Fractions whose numerator and denominator are natural numbers. Natural numbers means 1, 2, 3, 4, 5, 6. But there is a condition. The condition is denominator exceeds the numerator by 1. So how the fraction will look like? Listen, the fractions will look like 1 by 2, second will be 2 by 3, third will be 3 by 4, fourth will be 4 by 5, and so on. This will be the roster form for the given condition, because the given condition is numerator and denominator must be natural number, but the denominator exceeds the numerator by 1. So if we are taking numerator 3, denominator must be 4. If you are taking numerator 4, the denominator must be 5. Now how to write set builder from this? So set builder, let's write set builder for this. Okay, so x such that x is fraction is equal to n by n plus 1, and n belongs to what? Natural number. This will be the set builder form for this. Listen, n belongs to natural number. There is no capping. Take natural number till 10, take natural number till 20, take natural number till 100. There is no such capping. So we have to include all the natural number. So n belongs to natural number, and natural number starts from 1. It goes to infinity. So if you put here 1, so this will be 1 plus 1, 1 by 2. If you put here 2, so this will be 2 plus 1, means 2 by 3. If you put here 3, 3 by 3 plus 1, 3 by 4. So this will be the state builder form. And for such that, I have already told you, for such that you can use double dot, or you can mark a vertical line. X such that x is equal to n divided by n plus 1. N belongs to all natural number. I hope. Is it possible to write in both the form? Yes, this is possible to write in both the forms. Yes. We can put here and so on, because ending is not clear, right? Here ending is given 2 and 5, but we don't know so many numbers are in between 2 and 5 real numbers, so that's why not possible. But for this ending, we can put dot sign, right everyone? So this is possible. Clear? Moving ahead. Okay, now let's talk about belongs to and not belongs to. You all know this E represents belongs to. And for example, I am employee of Diksha Vedantu. So I can write Sonu Sir belongs to Diksha Vedantu. Sonu Sir not belongs to any other company. This is all about. Okay, so we have to fill the blanks. Y is present in this given set. Yes, so Y belongs to. 4 is not present in this given set, so 4 not belongs to, cancel. 2 belongs to, this is called null set, this is called null means 0, nothing. This is called 5 means nothing, but 2 is something, so it never belongs to this category. 2 is something, null is nothing. Okay, 5, x such that x is a natural number less than equal to 5. Yes, it belongs to. X is a natural number less than or equal to. If it would have less than 5, so it would have become not belongs to, but here is equal to, so that's why belongs to will there. So this is the answer. Okay, let's do few questions from your exercise of your advanced mathematics book. So list the elements of the following sets. So there are few questions given. List the elements of the following sets. Okay, so my dear, could you please tell me which format is already given? Oh my god, these are set builder form, because English languages are there. So sets are already given in set builder form. Now we have to convert in roster form. So how to convert? Listen. Okay, so x such that x is an integer and x square is equal to 9. X is an integer and x is equal to 9. So there are only two possibilities. If you put here positive 3 square will give you 9. If you put here negative 3, minus 3 square will give you 9. So let's say the sets will look like minus 3 and plus 3. This will be the answer, because these two values will be satisfying to this. Next, x such that x is a positive integer less than 5. Positive less than 5. So the sets will look like less than 5. Positive integers less than 5. 1, 2, 3, 4. This is the answer. Less than 5. X such that x is an even natural number divisible by 5. Wow, even natural number. So I am solving this C part. Even natural number divisible by 5. Divisible by 5, even natural number. So how many natural numbers are there? Even natural number. So listen. So the sets will look like first even. Come on, even. Even means the number which can be divided by 2, but the condition is divisible by 5 also. Wow, so the number should be divided by 2 as well as 5. So the first even natural number that can be divided by both is a 10. After 10, 20. After 20, 30. Wow, and so on. It will keep going and so on. So this will be the set 10, 20, 30 and so on, because these are the even numbers, natural number, and divisible by 2 because even number, and should be divisible by 5. So all 10, 20, 30, 40 all can be divided by 5. as well as 2. Clear everyone? D part, x such that x belongs to natural number and x is less than minus 1. X less than minus 1, natural number. Is it possible? Is it possible? X less than minus 1. Minus 1 means minus 2, minus 3, minus 4, minus 5, minus 5. And a natural number. Is it possible? Not possible. Not possible. So the answer will be 5. There is no such natural number. There is no such natural number which will go in negative form and less than minus 1. So answer will be 5. Answer will be 5. Null. 5 means nothing. Null. Clear everyone? Okay, so now moving to question number D. Is it clear everyone? Every question is clear? Okay, now move. Question number D is again already given in set builder form and we have to write the roster form. X such that x belongs to natural number. Natural number? So natural number always starts from 1 and it goes up 1 to infinity, positive. And here the condition is x should be less than minus 1. X should be less than minus 1 means minus 2, minus 3, left side to the number line. Minus 2, minus 3, minus 4, minus infinity. There is no such natural number. There is no any such natural number which will be less than minus 1. Not possible. Because all the natural number starts from 1, 2, 3 goes to infinity, positive. There is no any negative natural number. So this is not possible. And if this is not possible, so there is no answer. So this is called, result will be empty set. So for empty set we use this representation, or you can use phi. Phi also represents empty set. For this set builder format, there will be no element in roster form. Because this condition is not satisfied. This condition is not mathematically approved. This is violating the rule of mathematics. There is no any such number. There is no any natural number which will be less than minus 1. So this is called empty set. Clear everyone? Empty set. Or we can say null set. Null means nothing. No element is there. Empty set or null set. Clear everyone? I hope this is clear to you. Now my dear champion, let me tell you how many topics are left. So that will be discussed in the next lecture of sets. So I will be coming out with one more lecture of sets, and topics to be discussed is type of sets. So I will be teaching you types of sets. How many types of sets? Lot of sets are there. Finite set, infinite set, universal set, and many more things are there. So we'll be discussing these things. Then what is called subset? Subset represented by this. Not subset, it is represented by this. So we'll be talking about this symbol also. Then cardinality of set, Venn diagram, set operations, and application of sets. How you guys can apply set theory in your day-to-day life. So we'll be doing few numericals, few questions, few problems. Thank you so much for watching, and don't forget to subscribe the channel. And if you are the new student for the first time on channel, please share this video with your friends and keep coming. Stay connected with us. Thank you so much. Bye bye everyone.